UVM. This chapter is UVM phases. What are the UVM phases? All test bench components are derived from UVM component and are aware of the phase concept. Each component goes through a predefined set of phases, and it cannot proceed to the next phase until all components finish their execution in the current phase. So UVM phases act as a synchronized mechanism in life cycle of a simulation. Because the phases are defined as a callback, classes derived from UVM component can perform a useful work in the callback phase method. Methods that do not consume simulation time are functions, and methods that consume simulation time are tasks. All phases can be grouped into three categorized: build time phases, runtime phases, and cleanup phases. Right here, note that the run phase is launched in parallel with the other runtime phases. There is build, connect, and web elaboration, start of simulation, and run, reset, configure, main, shutdown, start of simulation and end of simulation, extract, check, report, final. Next is main UVM phases, build, phase category, build, UVM phase name is build phase, method type function, description, used to build testbench components and create their instances. Connect phases function, used to connect between different testbench components via DLM ports. The end of elaboration phase function, used to display UVM topology and other functions required to be done after connection. Start over simulation phase function, used to set initial runtime configuration or display topology. Run phase task, actual simulation that consumes time happens in this UVM phase and runs parallel to other UVM runtime phases. Frame extract phase used function used to extract and compute expected data from scoreboard. Oh, missing on check phase function uh, score used to perform a scoreboard that check for an errors between expected and actual values from design. Report phase function used to display results from checkers and summary of other test objectives. Final phase function typically used to a last-minute operation before exiting the simulation. Logically, the first thing to be done is create a testbench component object so that they can be connected together. This is the reason for build phase. It is better not. It's better to. It's better to not start connecting them while other testbench components are still building their subcomponent. So we have connected phase which will connect the components that were built in the previous phase. Although the next two phases are rarely used or are typically used to display UVM hierarchy information. Test stimulus is driven the design during the run phase, which is launched in parallel with other runtime phases that are described shown below. Why is build done top to bottom? Verification environment usually looks like a nested structure as shown in the image below. In order to build the agent, UVM environment is required to be defined, and similarly, in order to build the environment, the test class has to be defined, hence we can only go from top down. To add more flexibility, there are pre- and post-callbacks to all the time phrases. Why does the Verilog test bench need phases? A Verilog test bench would have all its components made of static containers or modules, so each module will have a set of ports or signals that it can utilize to communicate with the other test bench component. Since a module is static, all modules will be created at the beginning of a simulation, and we won't have to worry about any component getting called without it being created or initialized. It would be useful to have some rerun phases for resetting duty, driving the actual stimulus, and maybe another phase to enable and run checkers. Verilog test benches are limited in functionality and are not scalable. Why does system Verilog test bench require phases? System Verilog changes the whole game and the introduction of OP. Object-oriented programming features. This enables the creation of web structures and entities that can be reused and deployed when required. These entities are class objects, and it is possible to create a brand new object in the middle of the entire simulation, say at time x nano. What this means is that the test-bench components can be created at different times, and hence you could end up calling a component while it hasn't been initialized yet, leading to a wrong test-bench output. Also, different companies maintain their own hierarchy and arrangement of test bench environment, and it takes a lot of effort to plug in different verification IPs from other companies. So the synchronization between test bench component is a key requirement. So Thai, so next is what should be done in each UVM phase. The table below summarizes the intent, expectation, and the result of each phase as documented in the UVM reference manual. Phase build. Upon entry, top-level components are instantiated on the UVM root. Typical uses: instantiated subcomponent, instantiated register model, get configuration values for component being built, set configuration value for subcomponent. Exit criteria: all components have there are some mispoint. Sorry, create smaller size. So the top level typical uses instantiating subcomponents, instantiating register model, get lab configuration values for component being built, set configuration value for subcomponent. Exit criteria is all UVM components have been instantiated. Correct. All components have been instantiated. Typical uses: connect TLM ports and export initiator circuit and target circuits. Connect register model to adapt component. Set up explicit phase domain. Connection between the various components have been established. All independent phase domains are set. To elaborate end of elaboration, verification environment has been assembled. The display environment topology, open files, and define additional configuration settings. Now, startup simulation. External tools and simulation engines have been started and synced. The environment verification environment is configured and ready to be started. Display environment topology. Set debugger breakpoint. Set initial runtime configuration values. Run. Indicate the power has been applied. No active edges of a clock should have happened before. Component run over various runtime phases. Duty no longer needs to be simulated. Post underscore shutdown underscore phase is ready to end. Extract. Duty no longer needs to be simulated. Simulation time will not longer advance. Extract the data final state information from scoreboard test bench component. Prove the duty hierarchical reference backdoor access. Calculate statistics and summaries. Display final state information. Close files. All data been collected and summarized. Check phase. All data has been collected. Check that no unaccounted for data remain. Test is known to have passed or failed. Report phase. Test is known to have passed or failed. Uh, Report test result. Write test result to a file. End of test. Final phase. All test-related activity has completed. Close files. Terminate code simulation engine. Ready to exit the simulator. The user-defined phase. Creating user-defined phase. Creation of a user-defined phase in UVM is a possibility, although it may hinder incomplete reusability of the test bench. There are chances for component to go out of sync and cause errors related to a null pointer handlers. But in case you decide you have to use one for your project, keep reading. The common phase: build, connect, user, and elaboration, start of simulation, and run and restrict, and final. Here, user-defined phase. Some of the main steps to using a custom phase are: create and define a new phase class, add the new phase to existing schedule, use the new phase in component in support in this phase. Create custom phase class. First, 1. Extend appropriate base class for your phase type. 1. Class myPhasePhase extend the UVM task phase class myPhasePhase and extend the UVM top-down phase class myPhasePhase and extend the UVM bottom-up phase. Second, implement executed underscore task or exec underscore function method based on whether the phase consumed simulation time. Task and function like that. Task execute task, a function void execute function. Here's the complete example of a new phase class definition. Runtime phase. The pre-reset, reset, post-reset, pre-configure, and user-defined phase, and configure, and post-configure, and shutdown, and post-shutdown. The insert new phase into a schedule. UVM has a certain sequence of executing phases which you can review in phases. We can insert the new phase in between any of the existing phases, for which we have to obtain the handle through UVM phase scheduler or domain. A domain is a phasing schedule node that represents and independent a branch of a schedule. Individual phases are added to a domain, which will be inserted into the required schedule. First, get handle to appropriate domain. Second, get a handle phase after which you wanna insert. 3. Insert phase into a domain. Here's a complete example, and for our purpose, it has been included as part of the test case. This is simulation log. Note that the user phase was inserted after the connect phase as expected. Thank you. It was UVM phases.